What is up, Packet Nation? So DNSSEC, let's go ahead and dive into it. Now, a lot of people get DNSSEC wrong. They confuse it with encryption of their DNS information, but DNSSEC is actually sent in clear text. There's a lot you can still see on the wire. So let's take a look at what it is and what it isn't. So here's a full DNS lookup, and you've seen this on my channel before, and this is where you have basically a stub resolver, or it's a client just trying to resolve a name, and it goes to its DNS resolver, which typically has a cache. Now, if you're just in a home environment, or if you're in a small office, a lot of times this is your gateway or just a local device that caches everything that you're looking for. But on the back end, that's where the real stuff happens. So it's going to route name servers, TLD servers, authoritative name servers to fully resolve this name. More information on how all of that works in this video right up here. But DNSSEC, where does it fit in? Well, a lot of people think that it encrypts the conversation between the client and their local resolver, but that's actually not the case. The purpose of DNSSEC is it actually protects the cache of your resolver. What that means is when you ask for a name, there's not some nefarious person that can send a bad record to your cache and have it accepted. DNSSEC makes it so we know where that record came from and it's digitally signed. But what would a real video on this channel be like without actually diving into the packet? So let's do it. So I just open up a Kali Linux VM, and what I'm going to do here is first I'm going to generate a manual DNSSEC record. We're going to capture it in Wireshark, and we're going to see what we do and don't see. So to do this, I'm going to use the dig utility. I'm just going to look up cloudflare.com. You can see my query here. So cloudflare.com, and I'm going to do plus DNSSEC, and the DNS server that I want to use to resolve it is 1.1.1.1. It just manually goes out and it looks for that record. So I do want to use a domain that's digitally signed like Cloudflare. All right, so I'm just going to start up my capture over there, and I'm just going to run a little bit of DNS. So before digging into the packet, something I do like to do as well is just take this output that you see here. I'm just going to grab that guy. I'm just going to copy it, and I'm going to come over here to Cloud and pop it in. So this is one of the things that I use AI for, everybody. I get asked that question a lot on this channel. How do you use AI? What does it do? And what I'll do is I'll use it to validate outputs and also to walk me through what some of those header values mean and how should I interpret them. So I just pop that response in here, and here you can see that some of the flags that it actually did, the AD flag is the one that's really interesting. So here I can see that I've got a few different records here. So as I go through it in Wireshark, I can take a look at what each of those values mean. So let's go ahead and see what we found in Wireshark. So I'm just going to expand this, and I'll go ahead and link this packet capture in the description down below. So we can see that we got both DNS and ARP, so let's just focus on DNS here. So nice clean capture. That's what I like about capturing with Kali. It's not so chatty. I'm just going to take a look at the request. So first of all, DNS. So here I can see if I do my queries, cloudflare.com, type a record. I want an IP address to come back. Now additional records that I'm going to ask for. So if you come down here, you can see that I'm asking for, if you expand this Z, so the DO bit accepts DNS security RRs. So I'm actually saying, hey server, if you could just hook me up with that DNSSEC record, that would be sweet. So let's take a look at the response, specifically with DNSSEC. Okay, so we can see a response came back, no error. Answer authenticated. So the answer authority portion was authenticated by the server. Just good note to self to tuck away. So if I take a look at the queries, so cloudflare.com, and here's where I get these two addresses that came back. Now notice that this is not encrypted at all. This is wide open right there on the wire. So cloudflare.com, I get a couple of IP addresses that come back, but here's the question. How do I know that those IPs are legit? How do I know that I'm not just being redirected to a malicious site or an attacker is trying to in some way redirect me? Well, it all comes down to this resource record signature record, and that comes back from my DNS server. This means that this thing has been digitally signed. And just to step through this, and this is what Claude was helping me to step through just a minute ago, there's my time to live, data length, type covered. It's an A record, so those host records up there. The algorithm that was used to sign it, the signature expiration, the signature inception, key tag, and then signer's name. So cloudflare.com is the one that signed it, and here is the signature of that record. So this record is signed with the private key of Cloudflare.com, and this is the signature that I can use to validate that it came from where I think that it came from. So I just wanted to show you that on a short video. So when we use DNSSEC, it's right there in clear text. It's not used to encrypt DNS, but rather to validate that the responses that I get back from my DNS servers are coming from where I think they are coming from. It's to maintain the integrity of the DNS cache. Now, what does this prevent? Well, it prevents attackers from injecting malicious responses that I unknowingly might think are correct. So when I resolve DNS for any site, any domain that supports this, I know that I'm going to the correct server. I'm not being directed over to some malicious site with DNSSEC. So that's the point of DNSSEC. Now, as far as encrypting DNS, that's what we're going to discuss on our next video, so stay tuned for that.